All right. Welcome back, everyone. The cold continues. The snow is still with us. We're going to get more snow on Sunday?
Yeah.
Ugh, yuck. Okay. So listen. I want to go over these words to make sure that there's no confusion. I seem to be repeating myself every day as to what something means, okay? So let's start with the first one, really the easiest one, in a sense, and that's atomic number. Atomic number is the identifying number for an element. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, etc. 118 is the last element on the periodic table. Now, notice this, that every element has, is this true, by the way, Patrick? Does every element on the periodic table have its own individual unique atomic number?
Yeah.
Yes, of course. Now, that atomic number defines the element as that element. For instance, lithium has an atomic number of 3. That makes it lithium. If I said to you, what element is 79? You would go to your periodic table and tell me it's what? 79. What would you say it is?
Gold.
It's gold. AU, gold. Now, there are two major numbers in each square or rectangle on the periodic table. Can you see this? Is this coming up? Is this coming up? Can you see those squares?
To the left.
Or to the left?
Other way. And this way. That's
Okay. Okay. Now, you see the two numbers? The smaller number is the atomic number, and the larger number is what we call the mass number. Okay? Now, so the atomic number identifies an element as that element. If I said to you 10, you would tell me it's neon, Ne. If I said 20, it's calcium. So there's something very significant about the atomic number. Now, the atomic number has an abbreviation, okay? And that abbreviation is the letter Z. And the atomic number tells you this, Justin.
Yeah.
Do you know what it tells you? The atomic number? The number of what?
Neutrons.
The number of what?
Neutrons.
No, not the
Protons.
number of neutrons at all.
The number of protons.
It tells you the number of protons. That's the atomic number. So every element on the periodic table has a unique number of protons, and it is the proton that defines the element as the element it is. Clear? The next one is the mass number. Now, the mass number is not necessarily unique. You could have two mass numbers the same or very similar. It's the atomic number that's unique. But the mass number is the number of protons and neutrons. And it's identified by A, the letter A. That's the abbreviation for mass number. And this is protons plus neutrons. Now, remember, the proton has a mass of 1 atomic mass unit. The neutron has a mass of 1 atomic mass unit, right? So the mass number would be the number of protons and neutrons in the nucleus. So all you do is count them up. What's the mass number for calcium? It's 40. So if you look at the periodic table, can you see calcium there?
Right.
Can you see it? All right, so the smaller number is 20. That's the atomic number, so it has 20 protons. The mass number is 40. That has 40 protons and neutrons. Therefore, the number of neutrons is 20. If the protons and neutrons is 40, and the protons is 20, then 40 minus 20 is 20. Lithium. Look at lithium. What's the mass number for lithium? What's the mass number for lithium?
7.
7. What's the atomic number of lithium?
3.
I beg your pardon?
3.
3. So it's going to be 7 minus 3 is 4. So lithium has 4 neutrons. Atomic number of 3 protons. Mass number of 7 protons and neutrons. 7 minus 3 is 4. Clear? So I'm going to erase this. And I don't want to make this too long of a video. So I'm going to do maybe a couple of more words, then we'll quit and do another one. Clear?
Clear.
Okay. So a proton is 1 AMU and plus 1. A neutron is 1 AMU and it has a 0 charge. A neutron is neutral. Okay, are you participating?
Yeah.
Thank you very much. Okay, so the neutron and the proton, those are in the nucleus. Clear?
Yeah.
Okay. So I can erase these. Does anybody have anything to contribute for neutron and proton?
Nope.
The proton is what defines the element as the element. Neutrons are like the glue that holds the nucleus together. Clear? And when the element is light, they have similar protons and neutrons. For instance, helium has 2 protons and 2 neutrons, mass number of 4. Lithium is 3 and 4, etc. So they're similar. But then when they get heavier, you can see a major difference in the number of protons and neutrons.
Yeah, because the protons equals the element.
The proton defines the element as as that particular element.
Mm-hmm.
Every element has a unique number of protons.
Yeah.
But let me erase this and show you something. And it's this. It's this. Uranium 238. That's the mass number for uranium. Okay? And the atomic number of uranium is 92. And I know if I subtract that, that's 6. 13 minus 9 is 4. Good. And then 1. So it has 146 neutrons and it has 92 protons. So you can see here that the number of neutrons is much larger than the number of protons. So when the element gets heavier, the number of protons and neutrons varies by quite a bit. Clear? Okay. So now, let's quit this and go on to the next film. Okay, good.
Good job, Darcy. Aww.